All right, we are recording. Hope everybody had a good break, a couple of weeks off to kind of rest, recharge your battery, get back into it. So we are definitely going to get back into it this week. Even today with our trig identities, which we have right here, there's a few things I want to go ahead and bring to your attention. Your first quiz is going to be in a couple of days on Thursday, and it's going to be over the trig identity material from before the break. Okay, so you're going to be given an expression of some kind, and you'll need to go ahead and simplify it, just like we've been doing. And we're going to continue working with that idea today, in fact, this week on the next lesson. But that's what your quiz is. In fact, the first problem on the quiz, I did make it kind of a review problem of sorts, kind of a throwback. You remember one of those problems where it gives you a trig identity, and you got to determine what quadrant it's in, and then based on the triangle, give me another trig ratio? Okay, maybe we'll do one as a review in the next day or so, but number one is a review. There's only 5 questions, but 4 of the questions, the majority is going to be coming from the identities. All right, so I'm sure a lot of people just spend every day of the break looking over the identities, which is good because tomorrow we're bringing back an old friend, Happy Minutes. And the Happy Minutes are going to revolve solely around the identities. So the amount of time I give you is going to depend on what I ask you. So tomorrow I could say, list me all 6 of the cofunction identities. Or you could walk in one day and I say, okay, list me the 2 even trig identities and all 6 of the reciprocal trig identities. Or maybe one day come in, what are all 3 of the Pythagorean identities? So at this point, we do need to have those committed to memory. So if you're a little hazy on that, definitely take a little bit of time today, maybe tomorrow morning to look through this. In fact, let's see how well we're doing. How about, Skylar, give me any one of the 3 Pythagorean identities. He's already shaking his head no. None of them? Okay. Aiden, can you help him out? Without looking at your paper. Perfect. She says sine squared plus cosine squared equals 1. That is one of them. Shayna, can you give me a second one? I'm sorry? Don't know? Okay. Zach. Jay. Oh, now 1 plus cosine squared. No, we already got the sine squared and the cosine squared one. 1 plus something equals something. Well, you're not wrong. Okay. Enzo? One of the other 2 identities. Close. You have the right terms, but just not in the right order. Satish? Okay, there's our second one. 1 plus cotangent squared is equal to cosecant squared. Okay, so we've already had one identity with sine squared and cosine squared. We were given the other identity with cotangent squared and cosecant squared. Now, Enzo helped me out. We know the third identity has to have tangent squared and secant squared, but the order was just a little off. Christian, can you help me out on that one? No. Alyssa? No. Juan? No. Okay, how about Savion? Oh, no, we already got that one. Yes. Secant squared. 1 plus tangent squared equals secant squared. See how easy that was? Just like that. One of those categories, okay. So all these here, we definitely want to know those. Okay. Pythagorean, the reciprocal, the ratio quotient, cofunction, even, odd. All right, because I could ask you any of those categories or any combination. So we're going to start out. We'll do it all this week, starting tomorrow, all of next week. We'll start off taking them as daily grades, then we'll go to homework grades, and then ultimately this will become quiz grades. Okay, so we'll be doing this for at least 2 weeks to make sure that we're back up to speed on things. Okay, so any questions about that? Okay, we're still a couple weeks out from this, but I figured I might as well go ahead and let you know. Your first exam is going to be on Thursday the 24th. So basically 2 weeks from this Thursday. So the third week, we're back. This is the first week we're back, so we still have a couple of weeks. So we're still a little ways out. I haven't even started putting that together yet. So we know it's going to cover the identities, probably a little bit of other material, probably some difference identities, because we're going to start those hopefully at the end of this week and definitely next week. But we'll kind of see how that plays out. I'll give you more information as we get along. Also, you guys know you have a new seating chart. Obviously, you're in a different part of the classroom. Some people's seats changed pretty dramatically. Some people's seats changed maybe by 1 seat. But now in new seats, we have new villain buddies. So make sure you look around at those people who have the same colored villains, whether they be orange or purple, green, whatever. Okay, these are your new villain buddies when we go ahead and do those. And I think that is everything I have, unless anybody has any questions. No? No questions on the Happy Minutes, the quiz, and how excited we are to be back because it's been 2+ weeks without pre-calculus? You don't remember anything? Good thing. We're going to go ahead and start reviewing today. All right. So these are the notes that you picked up on the way in today. So I think this lesson might be even easier than what we were doing prior to the break, because what's going to be on your quiz, what we were doing then, was you just had an expression, you did not have an equation. Now, with these equations, we're verifying or proving that these are true. So you're going to choose one side, and it doesn't matter, the left side of the equation or the right side, and you're going to use the identities, manipulate that expression to get the other side that you didn't choose. And you'll see what I mean in just a moment. But I'm thinking this might be a little easier, because the question was always, when we were looking at these identities, well, how do we know what our answer is? How do we know how far to go? And with the equations, you'll know exactly where you have to stop. You just have to take one side and make it look like the other. Okay. That's exactly what number 1 here is saying. Pick one side of the equation, left or right. Usually it's easier to start with the more complicated side, the side that's busier, has a whole lot more going on. And I know that sounds kind of crazy, but you want to start with the side that's more complicated, because there's going to be more opportunities for you to manipulate it, maybe just by algebraically or using an identity. All right. Simplify that side until it's identical to the other. Don't work across the equal sign. So remember, we're not solving these equations, not yet. We're just simplifying them. Okay, one side to look like the other. Number 2, this is one we actually used quite a bit. We'll continue to use that. Change every expression to be in terms of sine and cosine. Number 3, look for algebraic operations you can perform. Everything from adding fractions, which means you have to have a common denominator, all the way through multiplying by a version of 1. The one I would like to go ahead and point out, multiply by conjugates. Okay, people today are not quite remembering exactly what conjugates are. What am I referring to? There you go. That's exactly right. So Christian said if you have x plus y, you would multiply it by x minus y. Yeah. So let me just come up with a binomial. How about 2x plus 5, 2x minus 5. Remember, they were binomial groups whose first terms were the same, but your second terms are, starts with the O. Opposite. So we got a positive and a negative. So basically it's that a plus b, a minus b form. Okay. In fact, if I multiply conjugates, I get a special type of factored binomial. What is that? Blank of blank. Difference of squares. Yeah, there you go. And when you factor difference of squares, you get conjugates. So those are definitely some good strategies. Number 4, look for trig things that you can do. If one of your trig functions is squared, I would definitely be thinking about one of the Pythagorean identities, those 3 that we just talked about. There's also an idea here, if you multiply cosine times secant, it's going to give you the same value as sine times cosecant, which is the same as tangent times cotangent, which is just 1. And let's look at one real fast. How could I rewrite secant? What identity comes to mind? The reciprocal, right? Secant is 1 over cosine of x. Well, then the cosines cancel. There's your 1. Okay, and you can do the same thing for both of the others. So if you ever see those expressions, if you're multiplying those reciprocals, well, they'll just be 1. Okay, keep looking at your answer. That's your goal, to make sure you're on the right path, and I'll show you how to do that today. Remember, is there going to be more than one way to solve these? Yes, I mean, we were looking at a lot of different problems, different ways right before the break. So the big idea is, don't give up. If you run into a brick wall, or you run into maybe an expression where you're not sure where to go, maybe start over again. Okay, as long as you're using your identities, you should be just fine. You should always be able to get to your destination. Okay, and then number 7. When you are finished, put QED at the end, because these are proofs that we're looking at here. Quadrarat demonstratum, which was to be demonstrated. Now, a lot of times this is probably the most commonplace expression to put at the end of a proof. This tells the reader that the job is done. Okay, I've accomplished what I set out to do. I've proved this particular equation or identity. Now, we never used this Latin expression when I was in college. When we saw QED, we read it as quite enough done. Okay, but it stands for the same thing. And it's really not going to be so important in here. I'm going to definitely make sure to go ahead and put QED at the end of the problems. But how many folks are moving on to calculus next year? This is definitely something that will be showing up next year when you're with Mr. Heinrich. Okay. All right. So let's get right into it. Now, we're not going to start with a trig equation because I kind of want to ease you into it. In fact, this is a rational equation. You might remember them from Algebra 2, solving these problems. We kind of looked at rational functions in here. I don't believe we solved any rational equations. Don't remember if we did. But the important thing is we're not solving for x. Okay, I'm not finding the value of x that makes this true. I just want to prove that this is a true statement. So of the left and the right side, which would you say is the more complicated? I definitely say the left side, right? So all I want to do is choose one side, like the instructions were telling me, and somehow I've got to manipulate this so that it looks like 2. And see, this is what I was referring to a moment ago. You want to go with the more complicated side because there's more opportunities to do things over here. You could start with the 2, but then you'd have to come up with an idea, how am I going to make 2 look like that? You see how it's easier to go from the larger expression to the smaller than vice versa? Okay. All right, well, somebody give me an idea. How can I make the difference of those 2 fractions look like 2? Okay, what do you think, sir? Perfect. Okay. The numerators are both difference of squares. So let me start with this first fraction. So we have x minus 1 as a denominator. So x squared minus 1, we were just talking about these groups. If you factor a difference of squares, you get what? Conjugates. What would those conjugates be? Yeah, x minus 1, x plus 1. And remember, the order doesn't matter. If you put the plus and then the minus, that's fine. Okay, so now minus. Then I've got x plus 1 down in this denominator here. Okay. And the same numerator is going to give me the same product. So x minus 1, x plus 1. Now here's what's really important. I'm not putting the equal sign because I'm not solving the equation. I'm choosing one side, and I simply want to make it look like the other. Okay. The only difference now is I know where I'm going. As before Christmas, it was open-ended. We didn't know where we stopped. Well, why was it a good idea to rewrite those numerators as conjugates? You can cancel group factors. Next, see, I have x minus 1 cancels with x minus 1. And over here, I've got x plus 1 canceling with x plus 1. Okay, so I no longer have fractions. X plus 1 is left here. What am I going to have to make sure to do? I got to distribute that negative. So this would be minus x plus 1, because I'm subtracting a negative 1, right? Okay. Well, does anybody notice what happens? Yeah, x minus x, those are gone. And 1 plus 1 does give me 2. See, we didn't solve it. I just need to change one side into the other to prove that this works. Okay. And what am I going to put at the end of this? QED. Quite enough done. That's what we're doing. Okay. Now, could this have been solved another way? Like if we didn't notice that the numerators were difference of squares, what else could we have done with the two fractions? Yeah, we could have found a common denominator, combined them, and gone from there. Okay. As long as you're following all your algebra rules, you're following those identities, you should be good to go. Okay. Now let's go ahead and get into the trig. Okay. So it says work with the left side unless the right side is obviously more complicated. And it's really always your choice. And a lot of these problems that we're going to go ahead and work on, you can choose to start with the left or you can choose to start with the right, whichever you believe is more complicated. In this one, I probably would go with the left because it has a fraction and then minus 1. Okay. So let's start. I have 1 over cosine squared of beta minus 1. Let me write this out. 1 over cosine squared of beta minus 1. And remember, beta is just a variable, okay, that Greek letter. If you have x or theta or alpha, that has no bearing on the identities. It changes nothing, okay? So if you're more comfortable just rewriting it as x, feel free to. It does not change anything. So I want to make this look like tangent squared of beta. Susie, what do you think? What's an idea? And see, isn't this exactly what we were doing before the break? Okay, the only difference is now I know what I have to get to. Okay, so Satish, what do you think? Use the reciprocal? Okay. There you go. 1 over cosine is secant, so 1 over cosine squared should be secant squared. Okay, so how does that help me? That is one of our Pythagorean identities. In fact, it was 1 plus tangent squared, and I'm going to stick with beta because that's what we have here, is equal to secant squared of beta. So if I were to subtract 1, remember it's not just the identities, it could also be a manipulated version of it. So see, here's the secant squared of beta minus 1, and it does equal what? Tangent squared of beta. QED. Okay. And some of these will be that quick. You won't have to do a whole lot in order to prove them. Now, will there be those that are going to take probably quite a few steps? Yeah, we're going to be looking at one of those today before you leave. Okay, but they're not all going to be huge like that. I know it's pretty sad because you want them all to be huge like that, right? Exactly. There you go. All right. Now, I know what you're saying. It's been over 2 weeks. I haven't had the opportunity to look at this material, Mr. West. I really want to try one on my own. Okay, well, I hear you. So let's try example 3. Prove the identity. Tangent of x plus cotangent of x equals secant times cosecant. Now here I'm going to let you guys decide. Should we work the left side or the right side? Okay, Stephanie, what do you think? What do you prefer? You want that? You want the right side? Okay, that's actually a popular choice today. A lot of people are going with the right. Okay. Now does that mean I couldn't use the left and make it look like the right? Okay, this one actually works both ways. It doesn't matter. But just so we're all on the same page, let's somehow try to figure out how can secant times cosecant give me tangent plus cotangent. Remember, this is what your quiz on Thursday is going to cover. You won't be given the equations. You'll be given just like an expression, and you'll have to figure out what it's equivalent to. So you won't know where to stop. Okay? Be just like before the break. Now, if you're already thinking, well, I think I have a better way using tangent and cotangent to get there, if you want to go from left to right, feel free. Okay. But I'm going to go ahead and use this. Give you a couple minutes to take a look at that. Okay, now we may not be done. Okay, or maybe you are done. Okay, but that's all right. Let's go ahead and see. Maybe someone's stuck. We can get them going in the right direction. So Stephanie chose the right side. Secant times cosecant. I want to make it look like tangent plus cotangent. Anybody have an idea? Now I'll tell you, you're on the right track with what I did on the right side, but not how we got there. Like, let me show you. Let me go ahead and erase this. Well, now remember, are these reciprocals? Secant and cosecant. They're not reciprocal, so I would probably go ahead and start just by changing everything in sine and cosine. That's really the only thing I can see to do. So this would be 1 over cosine of x. This would be 1 over sine of x, right? So if I were to multiply them together, I've got 1 over cosine of x times the sine of x. Okay. Did most people at least get to that point? Have the idea to change it? Now, this is where you might have gotten stuck. There is a Pythagorean identity that we can use here, but it's not very obvious. I went ahead and chose the numerator. Now, what identity do you think I went with based on what I have here? Which one? The sine cosine, the tangent secant, or the cotangent cosecant? Cosine and sine. Now, remember, that one says cosine squared plus sine squared equals what? There you go. So see, this one isn't as obvious as a lot of the other ones that we've seen, but I can still replace one with cosine squared plus sine squared. So cosine squared plus sine squared. And this is all over cosine of x, sine of x. So you see how I'm getting closer? See, I've already now got the plus that I need. Okay. Well, if you're going to add or subtract two fractions, you need a what? You need a common denominator, right? Well, that rule, like a lot of rules in mathematics, are reversible. There we go. Okay. Think about it like this. If I had something like x plus y over z, if I have multiple numerators that have the same denominator, well, I could break up each of those over the denominator. So I could say x over z plus y over z, right? Well, the fact that I have trig functions changes nothing. Remember, I think it was number 4 that's talking about the algebraic solutions. I can take cosine squared and sine squared and each break them apart over that common denominator. So I could say cosine squared of x over cosine of x, sine of x. There's the plus. Sine squared over cosine of x, sine of x. Now, how does that help me? Yeah, because what's going to happen in this first fraction? Yeah, you'll notice you got two cosines up top, one below, so one pair of cosines cancel. Over here, a pair of sines cancel. What's cosine over sine? That is cotangent plus sine over cosine, tangent of x. Now, we're looking for tangent plus cotangent, but is that equivalent? Yeah, the order in which you add doesn't matter. QED. This one, if you work the left side, it was probably a little more apparent if you went ahead and either used like a common denominator or just combined what you had. Okay. In fact, does anybody want me to go ahead and show that to you? Show you how the left can give me the right? Okay. Now, there is also another method that's not mentioned on the front of your packet, one of those strategies. Did anybody notice anything about the two sides? I'm talking about this in particular. Okay. What is tangent? That is sine over cosine, right? plus, what's cotangent? That's cosine over sine. Now, what if I did want to combine those into a single fraction? What would be the common denominator? Wouldn't it be sine cosine? Well, when you were to combine those, isn't that what you would get? Okay. There is another strategy. I personally don't use it myself very often unless I'm dealing with just a ridiculously hard equation, one of these examples. You can choose a side. You can go ahead and work one side to a specific point, like simplify it halfway. Then start on the other side and simplify it to see if you get to the same exact point. So it's almost like you can make both sides meet in the middle. Okay. Like I said, I don't personally use it a whole lot. I typically just go ahead and use take one side and go all the way to the other. Okay. But that is available. I thought I'd go ahead and mention that. Was anybody thinking that? Did anybody see you could do that? Nobody? Okay. Well, there you go. How are we doing so far? Yeah? Is it starting to come back to you? All right. Well, how about this? Okay. Now, this one, you're not given an equation. This is like a multiple choice problem. This expression, 1 over secant of x minus 1 plus 1 over secant of x plus 1, will simplify to either A, 2 cotangent cosecant, or B, 1 over secant. Let's see which one we're thinking of first, just a random guess. How many people think it's going to be A? Just before we get started. Okay, so a few folks. How many people think it's B? Okay, so for the folks who are not raising their hand, saying C, none of the above, it is not C. Okay, it has to be A or B. So it looks like we're pretty much split on that. And I know what you're thinking, man, Mr. West. It's been, again, a long couple of weeks. I have really been wanting to come up to that smart board and show a problem. That's the first thing I want to do on the first day back. Well, I got some good news and some bad news. The bad news is you might have noticed that this is a slightly different version of the notebook files I use. Okay. I don't know if you did notice that or not. Before the break, an IT gentleman came in and updated all my software, so it looks slightly different. So the bad news is there is no random number generator on this program anymore. So I can't use it anymore. But here's the good news. There is a random number generator on my calculator. So, again, all your seats are numbered. You're in brand new desks. Would anybody like to come up and show me this problem before the calculator chooses? God, I'm thinking I would have to just tell a whole bunch of people no, because all the hands will be raising. It's 2 weeks. You want to get up to the board, right? Okay, here we go. Number 15. All right. Aiden says I will do it. Now, I'm going to go ahead and at least get it started for her. Okay. I know that one of these two expressions is my destination. That's where I got to get to. So how would you first start? What's that? Okay, get a common denominator because we're looking to add fractions, right? So 1 over secant of x minus 1 plus 1 over secant of x plus 1. What is the common denominator? Yeah, it's just a product of the two denominators I have, right? So this guy right here needs secant of x minus 1. This guy right here, he needs the secant of x plus 1. And that's what the front page was talking about, a version of 1. Okay. All right, so I'm going to turn it over to Aiden because she looks really excited to get up here. Do you want the headphone? You sure you can talk to all the people? You all want to say hi? No? Okay. All right. Okay, so it looks like we're just going to go ahead and combine those all together. So 1 times the groups remains the same. Now, is everybody okay with how secant plus 1 times secant minus 1 is secant squared minus 1? Does anybody want to be shown that? No? Okay. All right. So she's going right to it. The two secants add, the ones cancel. Okay. Now, let's think about this for a second. What answer are we leaning towards, A or B? What do I have here that would help me make that decision? Why A? A has a what? Has a 2, and we just ended up with a 2. So I would kind of focus on my attention on trying to make it 2 cotangent cosecant. Okay, so Aiden, I'll let you continue. Oh, wow. Okay, hold on right there. I see exactly what you did, but is everybody okay with how she went from this to this? Really? There is nobody who has no idea how she went between those steps. Yeah, because the reciprocal of secant is 1 over cosine, right? But remember, you can go ahead and pull the numerator out in front. Okay, so does that help people? The secant squared minus 1 was actually part of a Pythagorean? Okay, if you guys tell me you're okay, then I'm going to believe you. Okay. Aiden, go ahead and continue. Let me give you a little bit more room here. So let's see. The cosines canceled, so we have 2 cosine over sine squared. Now, always be thinking about your destination. Hold on one second, man. Because we've got cosine over sine squared, and we somehow have to make that look like cotangent cosecant. So she says cosine over sine times 1 over sine. All she did was separate it using multiplication. That is exactly right. Perfect. Good. If I were to take these two fractions right here, whoops, sorry. Cosine times 1 is the cosine. Sine times sine is your sine squared. But now look at them individually. What's cosine over sine? Cotangent. There's your cotangent. And what's 1 over sine? There's your cosecant. So there is what we were trying to get to. And what do we put at the end? QED. Here we go. And maybe one thing you want to do as you go along, if you know what your answer has to be, like in this case, we saw early on that it had to be A. Well, we already had the 2. You know, maybe the part of the expression that you already need and that you have, don't mess with that anymore. Only take what's left and see how you would manipulate it to see what else you need in the function. Does that make sense? Okay. All right. Good. Good, good. Well, I'll tell you, you guys went through that faster than any other class today. That's as far as the other 2 classes got. Should we go ahead and push forward? You want to go ahead and push forward? Melissa says let's do it. All right. All right. Well, I'll tell you what. I'll go ahead and give you a 50-50 chance on this. If I go ahead and push enter and it gives me an even number, we'll continue. If it gives me an odd number, we'll stop. That's fair enough, right? So we want to see an even. We want to see an even. Oh, dang it. All right. So we'll go ahead and stop. Okay. Dang. I was thinking the previous 2 had been odd. It certainly did not work out that way. Okay. What is that thing?